Okay, long methods. Out of all the code smells we have seen so far, I think long methods are the most popular ones. What do I mean by a long method? A long method is one that is more than 10 lines of code. You might be saying, really? We have methods that are 50 lines of code and there is nothing wrong with them. Well, just because you're comfortable reading a 50-line method does not mean every other developer is comfortable doing so. In fact, on a scientific level, we humans can keep up to 7 things at a time in our conscious mind, which means when we read a method that is 50 lines of code, or 100 lines of code, or 200 lines of code, we have to keep track of a lot of things from the top of the method to the bottom. So there are essentially 3 problems with long methods. They're hard to understand, hard to change, and hard to reuse. Let me use a metaphor. Think of a chef. What does a chef do? A chef cooks, and that's what he or she specializes in. Now imagine a restaurant where there is only one person there and he is the manager. He's also the chef. He also takes care of shopping. He takes care of accounting. He welcomes guests and takes their order. What do you think would happen in that restaurant? I think people would run away the first night. And that's because of jack of all trades symptom. We want people who are specialized in certain things. So a waiter specializes in taking orders and welcoming guests. A chef specializes in cooking. You got the point. We want our methods to specialize in one thing. We don't want methods that are doing too many things. And when you have a method that is more than 5 lines, or let's say 10 lines, it's most likely doing too many things. If you have a method that is 250 lines, it's definitely doing too many things. Now take a look at this picture. Imagine all these lines are statements in one method, and that's a really large method. When we have a large method like that, that means some lines belong somewhere else in a different method, maybe in the same class or in a different class, but they do not belong there. Now the question is, how do I know which lines belong to what method? How do I know which lines should I take out? Well, we have a principle called cohesion, which means things that are related should be together, and things that are not related should not be together. So back to our picture, if we have a method like that, you see the lines that are blue are highly related, so they should be in method 1. The lines that are in yellow belong to a different method, and same goes for the lines that are in red or orange. And the same principle applies at the class level. Now imagine what you see on the left is a class, and these are all methods in that class. All those methods that are highly related should be in the same class, and those that are not related should go in a different class. If we design our classes or our methods based on this principle, we adhere to single responsibility principle, which means a class or method should do only one thing and do it really well. So back to our restaurant metaphor, we want methods that are experts. They specialize in one thing and do it really well. Now let's open up Visual Studio and see how we can refactor a large method into a set of smaller, more maintainable and more readable methods. Okay, you can find this example in the Solution Explorer under Long Methods folder. I found this code on a blog and I thought it's a great example to demonstrate refactoring of a long method. What we got here is the code behind for a web form called download. Inside page load, first we call this method create memory file, which basically reads a table from the database and converts its data into CSV format and returns it as a memory stream. Here we convert that memory stream to a byte array, and finally we write it to the response. Let's take a look at create memory file method. Just have a quick look here. See, it's a pretty long method. It's about 60 lines of code. And we want to break it down into a set of smaller methods, each less than 10 lines. So let's see what's happening here. The first block I see is about getting data from the database. Once we load the data, we iterate over the columns and write them to the memory stream. So this is going to be the first line of our CSV. Here we have a line break. And finally, inside this for each block, we write all the rows, as the comment here explains. So let's see how we can break down this method into a set of smaller methods. The guideline that we talked about was cohesion, which means things that are related should be together and things that are not related should not be together. Now, what I want you to do is to take a few seconds and look at this method. Do you see some parts that are closely related and are different from other parts? Just take a few seconds and think about it. Okay, the answer is this block is really about reading data from database. And it got nothing to do with writing these column names to CSV or the rows. So we need to separate out this block into a separate method. At this point, a quick way to fix that is to use the extract method refactoring, which you're familiar with. But I'm not going to do that yet, because we have a bigger problem. The problem is this method is actually doing things that are not related to this page class. Look, our code behind file here, this download, it's a web form, and web forms are about presentation. So all a web form should do is to display data. Where the data comes from, how it gets converted from one format to another is really not the responsibility of a web form. So this whole method, create memory file, should not be here. In fact, we need to extract a class from this method, then we can chop it up into a set of smaller methods. Now to do that, we put the cursor here on the method name, and then press Ctrl+Shift+R and select Extract Class. Give it a name, Memory File Creator. Okay, now in our code behind, we have only the page load method. Before taking a look at our new class, Memory File Creator, let's see if we can clean up this page load, because this page load already is too fat. Now take a few seconds and see if you can see some lines that are really related to each other and are different from others. Did you find it? So look, these lines, these 4 lines are all about clearing or cleaning the response. Now look at these 2 lines. This is all about controlling caching. So I'm going to separate them. These 2 is about the content and how we're going to encode it. So they're separate. And look, again, we got to pragma and expires, which is about caching. So I'm going to move this up here. And finally, we get to content type and adding content disposition, length, and finally writing the content. So all this is about writing the content. Now, what I'm going to do is to extract a method from each of these blocks. So let's start with the first one. Ctrl+W to select the block. Ctrl+Shift+R, extract method. I'm going to call it clear response. Same here. Ctrl+W, Ctrl+Shift+R. Let's call this set cacheability. And same here. Write content to response. So this method takes a byte array, which is our CSV converted to a byte array. So let's go ahead with that. And finally, look, these few lines are closely related. The first one tries to get that CSV as a memory stream. Then we convert it to an array, to a byte array. We flush the stream, which is really not required here, and then close it. These two look a little bit weird, and we're going to fix that shortly. But for now, let's just extract this into a separate method. Let's call this getCSV. Now we need to reorder the lines in this method. And basically the reason for that is in the first line, we're getting a byte array, which is the CSV. Then we go somewhere else. Then we go somewhere else and then come back to that byte array. Remember in one of the earlier lectures, I used a metaphor about storytelling. Like you ask your friend how was his day, and then he was telling you about his day and all these awesome things that happened, and then he says the world population is 6 billion. And here is the exact same scenario. We are telling a story here and then move on to something else and then come back to that story. So I want to select this line and move it down close to write content to response. So to reorder lines, press Shift, Control, Alt, and up or down arrows. So again, Shift, Control, Alt, and in this case, down arrow. There you go. Now, we can argue that this byte array is creating extra noise and it's really not required. We can totally get rid of it. So Control-Shift-R, inline variable. Now look at this method. It's only 3 lines of code. Isn't that clean? Look at our getCSV method. Only a few lines. Same for the other methods here. And we've got a bunch of unused using statements here. As you see, they're grayed out. I've got a plugin installed called Visual Studio Productivity Power Tools. I highly recommend you to download and install it. One of the great things about that is every time you save a file, it cleans up all the unused namespaces. Okay, now let's go to this class, Memory File Creator, and see how we can chop it up into smaller methods. So here's the original method that we moved to this class. Look, it's pretty fat. We don't want methods like that. We want our methods to be less than 10 lines, ideally 5 lines. So let's see what we can do here. Again, we're going to look for lines that are highly related and separate them from other lines. So this block here is all about getting data from the database. And it doesn't really have to be here. It can be in its own method. So we select it and extract method. Let's call it get data table. Good. Now look at the next line. Create a stream writer to write to the memory stream. This is one of those unnecessary comments that we talked about. It's telling me the obvious. So let's get rid of this straight away. Okay, now let's scroll down a little bit. So these few lines are all about writing the header, writing the column names. So let's extract a method here. Look at the preview. This new method has a few parameters that I don't really like I call count, stream writer, data table, just a little bit weird. So let's see what we can do here. This I call count. First of all, here is an example of Hungarian notation, which I explained in the first lecture. And we need to avoid that. Now, in this lecture, I'm not going to go to a full refactoring of this code because there are so many problems and I don't want us to get distracted from the topic of this lecture, which is about long methods. So let's leave other problems for now and just focus on breaking down a method into smaller methods. Now, what I want to do here is see if I can get rid of this unnecessary variable. So when we extract a method from this block, it doesn't have all these parameters. So let's select this. See, here are the usages of this variable. And yeah, as you see, it's spread all over the place. What we can do is we put the cursor here, Control-Shift-R, and select inline variable. So we got rid of it. We directly use datatable.columns.count. That's pretty clear. We don't need to store it in a separate variable. Now let's select this block again and do another extract method. It's getting a bit better. Now, in the list of parameters, we don't have that ugly I call count anymore. Let's give it a proper name. Write column names. Better. Now look at this next line. That's about adding a separator. I think this line should really be moved inside write column names because the job of writing column names is not finished without having a line break. So let's undo this refactoring and put this right line close to the for block and separate it from the rest. Now we select it again and extract method, write column names. Okay, much better. Now look at the next line. This variable is not used. That's why it's grayed out. So let's quickly get rid of it. Alt and enter and enter. Now here is one of those unnecessary comments that is stating the obvious. And if you remember in the comments lecture, I explained that when you see a comment trying to explain a block of code, that's a great opportunity to extract a method. So what I'm going to do straight away, select this block, extract method, write rows. Then we don't need that comment anymore. The method name is pretty clear. Let's take a look at our create memory file method. So it's much shorter than when we started. Now the next problem I see here is this catch block. So we catch an exception and we throw it. What's the point of that? That would only make sense if we were logging the exception here and then rethrowing it. So this whole try catch block does not make sense to be here. What I'm going to do is I put these few lines together, select them and take them out. Now select the try catch and remove it. Our method is now even shorter. Now look at this get data table method. This method is about data access, and it's not about creating a CSV, which is the responsibility of this class. If you look at the methods of our class, like write rows, write column names, these are about creating a CSV. So these are highly related, but getting data from database is not related to this job. So by having this method here, our class is losing its cohesion. We need to move this method somewhere else. In fact, there is another reason for that. If we move this method somewhere else, we can always reuse it whether we want to create a CSV or not. We can use that method to read a table from the database and load it into a data table. And then perhaps we can pass that data table to our create memory file as a parameter. So we can get any table from database and send it to this method and convert it to a CSV. So the next step is, instead of calling this method here, I'm going to introduce a parameter to our create memory file method. So we select this DT and Control-Shift-R, introduce parameter. I'm going to give it a proper name, data table. Now ReSharper found some conflicts. Sometimes it cannot continue with this refactoring and you need to jump in and fix the problems yourself. So this is an example of that. Let's go ahead. Basically what happened is we introduced that data table parameter, but that line get data table is now lost. So somewhere else we need to call that method and pass the result to create memory file. Where do you think that should happen? In our web form. So the web form would be responsible for calling that get data table and then passing that here. Let's have a look at that method for now. There you go. So here's our method, and as you see, it's not used anymore. First, I'm going to move it to a separate file. So we put the cursor on the method name, Control-Shift-R, move to another type. Let's call that class table reader. I want to change the access modifier of this method to public because we want to call it from the outside. So let's go ahead. Okay, let's take a look at the result. So here is our memory file creator, which is all about creating a CSV. So perhaps the first thing we can do here is to change the name of this class from memory file creator, which is pretty ambiguous, to something more meaningful. This class is responsible for getting a data table and converting that to a CSV. So perhaps data table to CSV mapper. And we can change the name of the method from create memory file to just call it map. Now let's get back to our web form. So as you see here, we have a breaking change as part of these refactorings. ReSharper could not work out what to do with this line here. So when we call getCSV, we need to pass the data table to the map method of data table to CSV mapper. We move that method, getDataTable, to a new type, and that type is called table reader. So what we need to do is to come up here, create a new field, table reader, it's not recognizing that. Let's see what happened. It's telling me cannot declare a variable of static type table reader. So let's go to this class with Control B. Because this method was originally static, when we moved it, ReSharper created a static class. And we forgot to change it to an instance method. So what we need to do is to get rid of the static keywords here. And now back to our web form. Okay, that problem is solved. So then here, we need to call tablereader.getDataTable. So like this. So back to our cohesion principle. Look, our web form here is purely responsible for presentation. All it does is get some data from somewhere, ask something else to map it, and finally present that. It's purely dealing with response. It's not going to the database. It's not generating a CSV. All of this is delegated. We have this class here called TableReader. Let's have a look there. This class is purely responsible for getting data from the database. Now, there are some problems with this method, like the name of the table is hard-coded here. We don't want that. Ideally, we would like a parameter here, something like string table name. I'm going to leave that for now because we don't want to get distracted from the focus of this lecture, which is about long methods. So you can do these kind of refactorings on your own and make this code cleaner. Also, as you see, the variable names are really poor, like DA, DS, DT. There is a lot of room for improvement here. Now back to our web form. We have a class here, data table to CSV mapper, which is purely responsible for one thing. And that's what the class name says. Let's take a look there. We have a bunch of small methods that are purely responsible for generating a CSV. The only thing that I think is a little bit too long is this method. Let's see how we can chop it up. Well, basically, we're iterating over a list of rows, and then we iterate over a list of columns. And here, for each cell, if it's not db_null, this is how we render it. Otherwise, we render an empty string. And here is the code for creating a separator. I think the first thing that we can do here is to grab this block, this for block, and extract it into a separate method called writeRow. So, see what I mean by that? Call it writeRow. Now, our original method, writeRows, is purely responsible for iterating over a list of rows, delegates the responsibility of writing a row to a separate method, and then adds a line break. Now let's look at writeRow. Here we iterate over a list of columns. And then for each column, or more accurately, for each cell, we need to decide whether we want to render an empty string or somehow format that value. So these few lines are really related, and they got nothing to do with this separator. So what we can do is we select this together, extract method, write cell. And here we can extract these few lines all together into a method called write separator if required. So see, now we have a bunch of smaller methods which have meaningful names, which do only one thing, and they're much easier to understand and maintain. The only problem we have is these parameter lists. We are sending out all these SW, DR, I. What does it mean? Let's clean it up a little bit more before finishing this lecture. So the first thing that I don't like here is lack of symmetry. Look, in this method, the first parameter is stream writer, then data row, and then I, which is the index of the column. Whereas in the other method in this class, stream writer is the second parameter. We have to have consistency. Personally, in this case, I would like this stream writer to be the last parameter for this method. Like when we're talking about write row, what is the first thing that we expect this method to receive? The row to write. And then we can send the stream writer. So let's do a bit of step-by-step refactoring here. First, we'll look at this method. We need to change its signature. Control F6. So here we select stream writer and move it down. Next. Good. Let's do the same here. Control F6. Select stream writer and move it down. See if we have got any other methods that are not consistent. Here's one. Control F6. So move down. Good. So everything is consistent now. Now look at this method. It takes 3 parameters. And as you learned at the beginning of this course, long parameter list is another code smell. Again, we don't really want to get distracted from the focus of this lecture, but I'm going to give you some tips here so you can clean up this code even more. Take a look at this dr parameter. Here are 2 usages of that parameter. And look, every time we use dr, we're also using I. So we don't need dr on its own, which means we can reduce the number of parameters of this method to 2 instead of 3. So the color of this method, let's find that with Alt and F7. So here, instead of sending 3 parameters, what we can do is to send dr of I, which is of type object. Now, as you learned, we're not going to do it manually here. We need to change the signature of this method. So I leave that as an exercise to you. Also, see if you can modify the parameters of other methods like this one here. Data table and I. What is I? At least change it, make it more meaningful. In this case, I is the index of the current column we are rendering. Overall, I think what we got here is a bunch of small methods that are highly related. And this class is said to be cohesive. It has high cohesion. Also, if you look at each of these methods, all the lines are highly related. We don't have distraction. The other problems I see in this code is this naming convention, which ReSharper is already complaining about. The use of memory stream and stream writer without the using statement. So if we get an exception here, who's going to dispose the stream? No one. In fact, I can argue that we don't even need to return a memory stream from this class. All we need here is a string. We need a string representation of CSV. And this way we make it easier for the clients of this class to use it, instead of every time having to read a memory stream into byte array or whatever. So, what I want you to take away from this lecture is to keep your methods short, less than 10 lines, and ideally 5 lines. Give them meaningful names. When you have a method that is only 5 lines or less than 10 lines, it's very likely that that method is doing only one thing. And this way you can give it a proper name that reveals the intent, which means you don't need to write comments to explain your methods. But if a method is 20 lines or 50 lines or 200 lines, which I have seen many of them, how can you name that method? It becomes really hard because that method is doing too many things. Again, whenever you're dealing with long methods, remember the cohesion principle. Find the lines that are really related to each other and extract them into a separate method. And as you're extracting these methods, see if those methods all belong to that class. If a method doesn't fit there, move it out. Put it in a separate class. And remember, all that comes with practice and experience. So it's not going to happen overnight, but if you practice what you learned in this lecture, you're going to get pretty good at it. I hope you enjoyed this lecture and thank you for watching.